Antarctica is the southernmost continent on Earth, covering an area of about 14 million square kilometers, making it the fifth largest continent. It is characterized by its vast ice sheets, which contain about 60% of the world's fresh water and 70% of its freshwater ice. Despite being covered in ice, it is considered a desert due to its low annual precipitation, which averages only about 50 millimeters along the coast and far less inland. The continent plays a crucial role in global climate regulation, primarily through its influence on ocean currents and its capacity to reflect solar radiation. However, Antarctica is undergoing significant changes due to global climate change. The Antarctic ice sheet is melting at an accelerating rate, contributing to rising sea levels. Recent studies have highlighted near-historic lows in sea ice extent and the potential collapse of deep ocean currents, which could have profound impacts on global climate systems. phys.org, NASA. Antarctica is also notable for its extreme weather conditions, with temperatures plunging as low as -89.2 degrees Celsius, -128.6 degrees Fahrenheit, recorded at the Vostok station. The continent experiences long periods of continuous daylight in the summer and perpetual darkness in the winter due to its polar location. In terms of biodiversity, Antarctica hosts unique species adapted to its harsh environment, including various penguins, seals, and microorganisms. The Southern Ocean surrounding Antarctica is rich in marine life, supporting large populations of krill, which are a crucial part of the food web. Scientific research in Antarctica is facilitated by numerous international research stations. The Antarctic Treaty System, signed in 1959, ensures that the continent is used for peaceful purposes and scientific research, prohibiting military activity and mineral mining while protecting the environment. Overall, Antarctica is a critical component of the Earth's climate system and a focus of intense scientific study due to its environmental significance and the changes it is currently undergoing. Currently, several significant events and developments are taking place in Antarctica: melting ice and climate change. The Antarctic sea ice has reached near-historic lows for the third consecutive year. This decline is attributed to global climate change, which is altering conditions in the Southern Ocean and impacting the region's ecosystem and global climate patterns. NASA. The melting ice sheets are also contributing to the slowdown and potential collapse of deep ocean currents that play a crucial role in regulating Earth's climate extreme weather events. Studies indicate that the Antarctic region is experiencing an increase in extreme weather events. These changes are likely to have global implications, emphasizing the need for reducing greenhouse gas emissions to mitigate further damage. Submarine landslides and tsunami risks. Research has revealed the occurrence of massive underwater landslides in Antarctica, which are significant geohazards with the potential to trigger tsunamis. These events can disrupt subsea cables and other infrastructure, posing economic and social risks. Environmental monitoring and research. Efforts are ongoing to understand and mitigate these changes. International research programs continue to drill and study the Antarctic seabed to gain insights into past climate events and predict future impacts. This research is vital for planning and implementing strategies to protect both local and global environments. These developments underscore the urgent need for continued scientific research and international cooperation to address the environmental challenges facing Antarctica and their broader implications for the planet. Antarctica is famous for several reasons, primarily related to its unique geographic, climatic, and scientific significance. Extreme climate and environment. Antarctica is the coldest, windiest, and driest continent on Earth. It holds the record for the lowest temperature ever recorded at -89.2 degrees Celsius, 128.6 degrees Fahrenheit, at Vostok Station. Its extreme conditions make it a unique natural laboratory for studying climate and environmental changes. phys.org, NASA. Vast ice sheets. The continent is covered by an immense ice sheet that contains about 60% of the world's freshwater and around 90% of its freshwater ice. This ice sheet plays a crucial role in regulating the Earth's climate by reflecting sunlight and influencing global sea levels. phys.org, NASA. Biodiversity and ecosystems. Despite its harsh environment, Antarctica supports a variety of life forms adapted to its extreme conditions. including penguins, seals, and unique microorganisms. The surrounding Southern Ocean is rich in marine biodiversity, with krill being a foundational species in the food web. NASA. Scientific research. Antarctica is a hub for international scientific research. The Antarctic Treaty System, established in 1959, designates the continent for peaceful scientific investigation and bans military activity and mineral mining. Research in Antarctica covers a wide range of disciplines, including glaciology, climate science, astronomy, and biology impact on global climate. The Antarctic ice sheet significantly influences global sea levels and ocean currents. Recent studies indicate that climate change is causing accelerated ice melt, which contributes to rising sea levels and potentially disrupts global climate patterns. Phys.org. NASA. Historical explorations. Antarctica has a rich history of exploration. Early expeditions by explorers such as Roald Amundsen, who was the first to reach the South Pole in 1911, and Ernest Shackleton, known for his remarkable survival journey, have captured public imagination and highlighted human endurance and scientific curiosity. Geological features. The continent is home to unique geological features, including the Transantarctic Mountains, vast ice shelves, and active volcanoes like Mount Erebus. These features provide insights into Earth's geological history and current geophysical processes. Antarctica's significance extends beyond its immediate environment, influencing global weather patterns, sea levels, and climate systems, making it a critical area of study for understanding and mitigating the impacts of climate change.